Up until this point, we've mostly talked about creating basic features from sketches using Pad and Pocket. In the previous episode, we saw how to extend those sketches with the pattern tool, as well as use Boolean operations to make combining or subtracting parts easier. Now, we'll start using a few more advanced tools like revolutions and pipes to create round shapes, and we'll end with a demonstration of lofts, which allow you to make more organic designs. I'll show you how to make this custom keycap for a mechanical keyboard. We'll need to use pipes to make the rounded surface, and we'll use lofts to design the top. Along the way, I'll show you how to use the revolve and subtractive pipe tools. In these last few episodes, we'll look at more advanced tools, which allow you to make complex shapes. We'll start by looking at revolutions, pipes, and lofts. To begin, I'm going to show you how to use the revolution or revolve operation. We're not going to use that in our final design, but it's a way for you to understand how that tool works, as it can save you time on some designs in the future. Make sure you're in Part Design, click New Document. Let's create a body in that document as usual. I'm going to create a sketch, and this time I'm going to do it on the XZ plane, because I'm going to create a cross-section of something I want to revolve. To show this multi-line or polyline tool, click on that, and notice that my icon changes. In fact, I'm going to exit that tool and show you the hotkey for this, which is you press G first, I guess for geometry, and then M for multi-line or polyline. I'm going to create a line out here, so let's just do something like that. You can press M to change it, and I'm going to change it to this arc. I'm going to bring this down, sure, and then we're going to bring it down something like that, and let's come down here, and let's close this out. When we close it out, you notice it turns orange, and there is a redundant constraint. That is because when I put it on this line, this axis, it automatically gave it the horizontal constraint, which we don't need. That is redundant. So delete that constraint, right-click to exit that tool. I'm going to give it some arbitrary constraints. Notice that I can kind of move these around, and I think that looks pretty good. So let's just click, enter, click, enter, click, enter, click, enter, click, enter. How many degrees of freedom do I have? 4 left. Let's go ahead and set these angles. Sure, that looks good. Let's set these angles. That looks good. I'm going to right click, press V for vertical. Let's set that to vertical. Where's my last? That far away from the origin. So I'm going to click this. Let's do horizontal. And let's make it 70. Sure, now it's fully constrained. You can do this without fully constraining this if you want to save time, but it's generally a good idea to fully constrain your sketches when you are making something. I'm going to turn these planes on so you can see what's going on. So we've got this cross section. If I were to use the Revolve tool right now, notice nothing happens when I click it. So I need to click this sketch first, then click the revolution tool, which it's not happening. Oh, I clicked the origin. Let's click the sketch, then click revolution. And it's going to default around this Z axis, and it creates this nice big donut. I'm going to click cancel. What happens if I want to create it right here? How do we do that? As you can probably guess from previous episodes, we can use something called a datum line. So if I click that, that's going to put the datum line in the Z-axis. You can kind of see this yellow peeking through this line here. So if I remove that, you can see that's where it is. I want to attach it to this point here, and then we're going to move it off of that. In the tasks bar, or you can double click on the datum line to bring this up, I'm going to delete this first, this reference. Then I'm going to put it on this line. Notice that this line's vertical. We could use that, but let's attach it to this point. There's an issue here that it doesn't like having a single point as its only reference. So let's click selecting, or the select button, and now it wants to select the Z-axis, and that kind of gives it a direction. So between these two, we now have it vertically placed on the sketch, kind of where we want to revolve around. So click OK. Come back to your datum line, click on it to get the properties, and let's adjust its position, I believe, along the x-axis. So we actually want to, let's say, -2 mm. That brings it off here, and that's going to give us a nice little hole when we revolve. So click anywhere to exit out of that. Let's hide the origin planes. Now we're going to click the sketch. We're going to click revolution. It's going to default to the z-axis. And instead of the vertical sketch axis, we're actually going to select reference, and we're going to select our datum line. And there we go. We have created a revolution around that line. Click OK, and that is our part. I don't know what you would use this for, maybe some sort of countersink, standoff, but hey, it works. This would be another good way to create the complex disk that we made in the previous episode. This can help a lot with things like tubes, disks, and other parts. Go ahead and delete this body, as we're not going to use it any longer. We're going to make something else.
For fun, let's make our own keycap for a mechanical keyboard. I've got Cherry MX switches on 2 of my keyboards, so these dimensions should, in theory, work. Notice that the keycaps have a slant to them, depending on the row. We'll create something that's symmetrical in both X and Y axes to make this easier. The internet can also give us information about the stems that mate with the switches. This stem height isn't exactly right, though. From what I can tell, the stem should be 1 mm from the bottom of the cap.
In our empty document, let's create a new body. We'll create a new sketch, and we are going to sketch like we did last time on the XZ plane. I'm going to use the multi-tool, which is the polyline tool. And if I try to create something, I can't press M. That seems to be a bug where I can't change the type of line with my very first line. So I'm going to exit that. Let's try this again. I'm going to create the bottom of this keycap here. I'm going to press M. Create this rounded edge like that. Press M to get a line, something like that, something like that. Come back in, press M, and we're going to connect these like that. Right click to exit the tool. That should be good enough for now. 3 is a redundant constraint, so let's find that in my constraints. Press delete to get rid of that. And let's start defining some constraints. So horizontal, this line should also be horizontal. Press V, this line should be vertical. Right click to stop that. And it looks like it's trying to make these points tangent, which is weird. Oh, nope, those aren't tangent. Those are concentric. This is tangent. Yeah, so that's not moving. We need to get rid of that constraint. So click on that constraint, that tangent constraint, press delete, and your points should be connected, no longer. So it looks like that's coincident to this axis. So let's make these two coincident. And we want to make these points line up. So make these points coincident by pressing C, making those 2 points line up. And we're going to bring this, it is not liking that. Let's make this a little higher. That's what's going on. This is tangent here. So click that, delete it. These two are now separated because it's not a red dot. So C, make these 2 points coincident. Right click to end that tool. Now that's a lot better. So we want to bring this like somewhere over here. We want to make this coincident with the x-axis line. We're going to bring this back in. That's looking a lot better. Now we can define our dimensions. I want this to be 2 mm based on my experience. I want this to be 1.6. 2 mm was a little too thick for what I was trying to do. We're going to make this underside 2 mm as well. And we're going to use the dimension tool to set the height. Notice that it's trying to define a distance to the origin right now. So if I click on that extra point, where I move this distance tag or this label determines what kind of distance it is. Right now, this is just pure point-to-point distance. If I move it to the side here, that creates the height. So that is only in the y-axis, or I can move it above it, and that puts it in the x-axis, so above or below. That's the horizontal length. So I want the vertical length, and I'm going to set this to 10 mm. And that vertical length would be the same as doing this drop down and going constrained vertical distance versus constrained horizontal distance. I want to make this point, based on some experimentation, about 25 mm away from the center of these arcs. Feel free to play with that value if you wish. I'm going to move these back in. We should only have 1 degree of freedom left. Distance tool, I'm going to go from this point to the origin, and I'm going to make that 9 mm. There we go. Right click. We are fully constrained. That looks good. So close out of this sketch. Now we want to create another sketch. We're going to do this on the XY plane this time, and we're going to define the path for this pipe to follow. And we want to connect it to this corner here, but we're going to draw it on the XY plane at first and then move that sketch up. And then we're going to use the pipe tool to create a shell for us rather than doing, say, a revolution. This allows us to do complex paths. I'm going to go back to top. I'm going to bring in this top line as external geometry. Back to top again. I'm going to slice my view so I can see what I'm doing. I'm going to use a rounded rectangle, so feel free to drop down, rounded rectangle, draw that wherever you wish, and set your fillets. Right-click to end that tool. Use the coincident constraint to attach this point to this line. Right-click, S to do symmetrical constraint. Let's do it across these 2 points around the center point. And we have 2 degrees of freedom left, so width and height can change. So E to set the equal constraint, one of the top lines to one of the side lines. Right-click, and now the only thing we have left is these fillets. And I think a 1 millimeter fillet is pretty solid. Right-click, and we are done with that path. So close out of that. And if we come to the top here, you can see that path is well defined according to where this point is, but we actually want to connect it to this point. That helps the tool understand we want that point to follow this path, and it will pad around it. So to do that, we actually need to name this height constraint because I like to be parametric where I can. So let's go back into the sketch where I set the 10 millimeter height here. We're going to give it the name height. And while we're at it, let's name this thickness. We're going to call this top thickness. Click close to get out of that. Come back to our sketch, and we need to move this sketch. Let me turn on the planes for you so you can see what I'm doing. I'm going to move this plane. I'm going to move this sketch up in the Z-axis so that it touches this point here, and we're going to do that parametrically. So go to the sketch, go to position. Let's use the equation editor, and we are going to go into sketch. We're going to get the constraints from sketch, and we are going to get that height, which should be 10 millimeters. Click OK, and now that sketch should be touching this point here. The order in which we select the sketches for this tool is very important. You want to select your cross section first, which is sketch 1, so that's going to turn green for us. Then press and hold Control, and then select your sweep path next. So I'm going to select that one. Then I'm going to select additive pipe, and that is going to sweep that profile around that sketch. And that looks like a really good keycap to me. Let's keep that orientation mode as default. We're going to keep everything else as default. Click OK, and we have a nice sweep or pipe. We now want to fill in the top of this keycap, and we can do that by using this sketch again. So select this sketch, click the pad tool, click reverse, and it's going to fill it in, but it's going to fill it in a little too much. So let's change this to sketch. We're going to go into our constraints, and we're going to use that top thickness. Click OK, and now it's parametrically defined with that first sketch. So now it's perfectly filled in with our keycap. So this is our basic shape that we are working with. Next, we need to define the stem that comes down and connects to the switch. So let's click on the bottom of that new pad we just created. We'll click Sketch, and I'm going to slice the view so we can see what we're working with. I'm going to press G and M to select this polyline tool. I guess M for multi-line. And I'm going to create a quick sketch that I know worked for my purposes, where I'm going to create kind of a stem holder here. And I want that to go that way, and we'll just connect these lines. Good enough. So right-click to get out of that tool. Let's set some constraints. So I want this to be horizontal, this to be horizontal. These two are horizontal already. V for vertical. I want that to be vertical. I want that to be vertical. So all of these should be horizontal and vertical. I want these two arcs to be the same. Right-click, and I definitely want this line to be vertical. Right-click out of that. I want this distance from this line in the horizontal sense to be 3 millimeters. Right-click, That created a little bit of a weird gap for us. So I'm going to adjust the shape some so we can see what we're doing. Based on a bunch of failed prints, I want this distance to be 1.61 millimeters. Right click out of that. I want these two to be symmetric around this line. So as you can see, I can move these up and down. So S, I want this point and this point to be symmetric around that line. Right click, and that looks pretty good. I want the height of this, the whole thing, to be 4.4 millimeters. Right click. Oops, you can see if I moved it there on accident by dragging, I can just click on bottom to rotate my camera back into position. I want the fillets to be 1 millimeter. Right click to say I'm done with that tool. 3 degrees of freedom. What do I have left? So this can move. I'm going to set a distance between this and this line. This horizontal distance is going to be 0.805 millimeters. That's once again based on some testing. I want the distance between this line and this line to be 2.2 millimeters. Right click, 1 degree of freedom left. What do I have? This moves up and down. So a couple of ways we can fix that. Easiest way is probably set this line equal to this line by using the equality constraint. Now I'm going to flip this over here. So drag and highlight the whole thing. Let's mirror that. Click this line. And now we're back to 7 degrees of freedom. With this, we can figure out what's going on here. So it looks like we can probably set some symmetric constraints. So S to select these across this line or around that line. That solves that problem. Let's use equality to set this line and this line to be the same. Right click. Let's set equality to be this line and this line. Right click. Looks like we need to set this distance here. And one way I like to do that is just to name this half width. So we're going to use the smart distance tool to go from origin to this point, and we're going to make that a horizontal distance, and we're going to set that equal to constraints dot half width. 2 degrees of freedom left. Okay, we can move this in and out. Let's set this equal to that. Right click. What do we have left? So in and out here. And let's call this one half gap. We're going to do the same thing we did before. We're going to use the smart distance tool. We're going to go between either this line, or I like to use the origin, and this line, and we're going to set that horizontal distance. We're going to press equals to go into the expression editor. Let's go constraints dot half gap. Right click, and we are fully constrained. So click close. And remember, we wanted that 1 millimeter gap here. So we're going to set that parametrically as best as we can. So select the sketch, select your pad. Let's go to the equation editor. Let's go with that first sketch. We're going to go into the constraints. We're going to get the height, which was 10 millimeters. We're going to subtract, not equals, subtract sketch dot constraints dot top thickness, because we want to remove that thickness from where we started. That was 2 millimeters. And then we're going to subtract out 1 millimeter. Click OK, and you can see that's now padded down, and it doesn't quite reach the bottom there. So that keycap should work and cover the switch as needed, and the stem still fits in here. I'm going to give you a quick demo of the groove tool, which is kind of like a subtractive pipe if you ever need to like carve something around an object. Let's click OK to make sure we exit out of that pad operation. We're going to sketch, and we're going to do it back on the XZ plane. I'm going to take some arbitrary shape here, and we're going to carve some interesting pattern. I'm not even going to worry about constraining this. So let's just move this in, do something like this. Let's just carve it in like that. Don't worry about constraining it, because I'm just going to delete it in a minute. So we've got that sketch kind of poking out of the side there. And I'm going to create a sketch on the XY plane. I'm going to bring in, let's say, this outer edge. So, well, let's use this here. I'm going to click all of these. That should be fine. Right click. Let's slice that view. I'm going to use my rounded rectangle as we've done before, set my fillets, right click. Let's set this point to this point. That did not work. Control Z. There we go. I want to set this point, that point to that point. Much better. I'm going to set equals this line to this line and this line to this line, and then set my fillet arcs to be the same. That should fully constrain it. Close out of that. Click the first sketch, click the second sketch, and here is the groove, which is more or less a subtractive pipe. You can see it carves this really funky shape all the way around. In fact, I probably made it too big and it's dropping holes there. Let's say okay. I'm going to go back into that sketch. Let's make it a little bit smaller or out of the way. Close. There we go. That looks a lot better. I don't know how thin that wall is or how useful this would be, but now I've got this funky pattern. So I hope that demonstrates how that groove tool works. Let's delete the groove. Let's delete that sketch, and we are back to this basic keycap shape. Now, you have a blank canvas to do whatever you would like on the top of this keycap. I'm going to demonstrate the Loft tool, which is actually really cool. It allows us to make multiple sketches, and then the tool intelligently fills in the gaps between them. Before we do that, though, I would actually like to bolster this, because these are so small that they might break because they are 3D printed. So let's come in here, let's create a new sketch on the XZ plane. Let's slice the view so we can see what we're doing. And I want to bring in this as external geometry, this as external geometry, this line as external geometry, and probably these two lines. So let's right click, we'll go to front. We can see where we need to create some sort of brace structure or ribbing in here, which helps keep the structure. To do that, I'm going to create a super basic rectangle. Right click. Let's get rid of this vertical constraint. So click on that constraint icon, click delete. Now we can make this like this. This doesn't really need to line up with anything. It just needs to be in there. So we could put it on that line if we really wanted to. In fact, let's do that. Let's attach it to here. Let's attach that to there. And let's attach this line to this line using the coincident constraint tool. And we're going to attach this point to this point. There's a redundant constraint, which is number 10. Let's get rid of that. And now all we have is 1 degree of freedom, and that is the height of this. So dimension tool, let's bring this out. I'm going to make this 3.5 millimeters. At least for my testing, that should work with my keycap stems. Click close. And if we spin this around, we can see under here. And we are going to pad that. Let's do it symmetric to plane, and let's make it about 2 millimeters. So that's a nice rib that we have going on in there. Click OK. Click that pad. We're going to use the polar pattern tool. See, it did not want to go around that shape correctly. So what we want to do is click the Z-axis as our axis, and that should go around there. We're going to do occurrences 4. That should create ribs all around. And I think I see a problem where these ribs don't go all the way up to that point, which we want them to do. But because this is parametric, we can say okay. We can go back into our plane here. We can go back into our sketch here. We can find where that coincident constraint occurs, delete it. We should be able to bring this inside, and let's make it coincident with that line. Right click, say close. Oh, much better. So those are pretty much now connected. I don't know if that's going to 3D print well, but at least there's no gap between this ribbing and this stem shroud. That looks really good. I'm happy with that. And now we are ready for the loft. Let's click this top face here, and we're going to click create sketch on it. And let's create 2 circles. next to each other, like here and here. I'm going to let you be somewhat creative with this, so I'm not really going to constrain these very well. Let's make this one about yay big, and let's create a couple of lines that connect the top and bottom. I'm going for a teardrop shape here. We're going to connect this to this. Right click. These can kind of move around, and what we want to do is press T for the tangent tool. We want this to be tangent to that. That's okay. It looks like that already applied down there. We want this to be tangent to that. That's okay. It's just saying it's taking away that coincident constraint and replacing it with a tangent constraint. And now we've got this teardrop that we can play with. But you notice we've got these internal circle arcs. This trim edge tool is really useful for stuff like this. We could just click that and it removes that arc that's internal. And now we've got that teardrop shape. And I'm going to make it a little bit bigger. Oops. Bring it up. And I'm not going to even fully constrain this because this is kind of a creative endeavor that we're doing here. Click close, and that's the start of the little teardrops that we're making. We want to copy this and then modify it slightly. To copy a sketch, what you want to do is right-click copy, and you're presented with this really weird dialog. It doesn't copy and paste like you're used to. It tries to copy everything in the body. So we're going to select or deselect all. We just want to select sketch 004. Click OK, and then you can right-click or press Ctrl V, select paste, and you'll notice that the sketch appears outside of the body, which is really annoying. This happens every time. So I'm going to take this sketch, I'm going to click and drag it and place it in the body. So now when I drop it down, I've got sketch 4 and 5. Let's make the body appear again. And I'm going to offset this sketch 005 by 0.5 millimeters. So press tab to get out of that or click out of it, and you can see we've got an offset sketch. Let's double click to go in and edit that sketch. And I'm going to move this in just a little bit, move this in just a little bit. There we go. That's what I want to see. I want to see that other sketch. I don't know why that's not showing up. I'll rotate the camera just a bit so we can see what we're doing here. Let's move this out. I want it to be fairly close. Yeah, I'm liking the way that looks. Let's move this one in a little bit because I want this to slope down more than the backside. Okay, so no need to fully constrain that. Let's repeat this process. So I'm going to right click, I'm going to copy this. I'm going to deselect all, select sketch 5. I'm going to paste. I'm going to drag it inside the body like that. And then I'm going to double click to edit it. Nope, first I'm going to offset it before we edit it. So go to position. Let's offset this by 1 millimeter. And so we double click. Now we can edit it. I don't know what this weird graphics glitch is, so I'm just going to rotate the camera ever so slightly so we can see what we're working with here. We're going to make this a little bit smaller, a little bit smaller. We're going to bring these in like so. And I'm not ready for that to be quite that big yet. We're going to try to make these somewhat parallel. Once again, this is an artistic endeavor. Let's bring these in just a little bit. Let's bring these out. And I want to bring this back, but I want to bring these in to do that. Ooh, this is fun to play with. There we go. I can just drag them like that and then bring them in. Hey, that looks good. Close that. Let's do this one more time. So copy that sketch. Sketch 006. In fact, I'm going to do Control V. It pastes it below. Drag it into that body. It appears down here. Double click, but not yet because we need to offset it by, let's do 1.3. This is going to be our top layer. So you can see it's showing our sketches here. So 7 is here. We're going to double click to edit that. And we're going to make this one really small because this is the top piece of our teardrop shape. I'm still going to try to keep this somewhat parallel. It seems to be rather difficult. And a little bit, oh, come on, a little bit more adjusting. I could make them fully parallel by using the constraints if I wanted to, but it's fun to try to demonstrate a little bit of art here among all these constraints. I'm going to keep dragging. And let's bring this back. I think that's pretty good. Bring this in a little bit. There we go. That should be pretty good. So close out of this. And now we have our 4 sketches that define our loft. And we're going to use the Loft tool to interpolate between these sketches. So to make this work, I like to control click each of the sketches to highlight all of them. And I believe order matters here, in which way you want the Loft tool to work. So if you try to do like 5, 7, 4, 6, it would try to interpolate in that order and end up with something really weird. So let's go from the bottom sketch up to the top sketch. So with those selected, come up here to the Additive Loft, click on that, and you'll see the yellow that demonstrates the loft that's going to happen. Ruled surface basically means it's not going to do a nice curve for us. So this can be useful in some instances. So I'm going to deselect that, and you see we have that nice curved loft. I'm going to leave closed open. You can also add or remove sketches here, and I'm going to click OK. And we've got this nice little bump that is our teardrop, and that looks actually pretty good. And this is how you start getting into curved surfaces for making more organic shapes. And there's lots of ways to do this. This is probably the easiest way to do it, even if it's a manual process of defining your cross sections at every point. Make sure these sketches are hidden. In fact, I'll show them. You can actually see how it interpolated among these sketches. So let's hide those. We're going to click on the Additive Loft. We're going to click on this polar pattern. And we're going to make sure that the axis is the z-axis for this whole part. And we're going to make, you could do 6 of these for fun. Oh, that looks so weird. We could do 4 of these. And now it kind of has this like molar tooth looking thing, which I'm sure feels really weird when you're typing. And to me, that's a lot of fun. So let's go with that. So click OK. And our keycap is done. Feel free to file, save as. I'm going to save this as custom keycap. We're going to click on the body, and we're going to go File, Export, Custom Keycap Body. That's fine. Overwrite it, and we're ready to slice and print it. I'm going to import the part into my slicer. So this is Custom Keycap Body. You can see it here. Because this top is not flat, I'm going to need to build it with support on the bottom here. So I'm going to generate support. And as much as I like tree support for a lot of things, so we can do tree, I find that tree often is really tough to pull out of small cavities like this. You can't really break it. It's a pretty hard structure. So sometimes I like normal. Zigzag's good. Lines are also good. You can change the density. This isn't too bad. Or something like grid. So feel free to play around with some of the options. Grid looks really good. I should be able to get something in there to pry it free. Let's go ahead and save this and print it. Yes, overwrite, and we'll send this to the printer.
Because the part is so small, this is a relatively quick print, only about 30 minutes. Clearing out the support material is a little bit of a pain. If I had a resin printer, that would make this process easier, and it would allow me to print more intricate designs on the top of the keycap. With the keycap cleaned up, we can now put it on the keyboard. It doesn't match perfectly with the rest of the keys, but it's a fun customization that actually works. If you'd like a challenge, try creating your own keycap. Okay, I know not everyone has a mechanical keyboard. If you don't, maybe try making a custom knob for some household appliance. If you'd like, share your designs on X, Instagram, or LinkedIn with hashtag DKFreeCAD and tag DigiKey. Next time, we'll dive into some advanced features so you can create organic curved surfaces.